Hello and welcome to CppChat. It's the first episode in a very long time, so I want to take just a moment and welcome people back or welcome people for the first time. We've been silent for, well, here's how we keep track. I always want to talk about CppCast and what they talked about. So here's my list of the CppCast sessions that have happened since the last time we were on. It's been about 4 or 5 months. We went silent right before CppCon in September and haven't been on. And now I am trying to be back to a weekly schedule. So we're going to be joined by people who, mostly you'll find they're people who speak at conferences. I wonder why that is. But in general, there are people who are going to join us and we're going to talk. The nature of this show is that we talk about the news of the week in what's going on in C++. It may be news, it may be gossip, but that's what we try to do with different people and kind of get some different points of view. And so I kind of want to contrast this with CppCast. They are a news format show. They do a little bit of, they usually talk about a couple of news items. And this week they gave a shout out to us. I love that. That's terrific. And the other big difference, and so we kind of have a news discussion format and they have more of an interview format. The other big difference is that those guys are really professional, and that's not really what you're going to find here. So
welcome to Amateur Hour.
So I do want to introduce the people joining me today. So let's start with Ben. You want to say hi, Ben? This is Ben Dean.
Yeah, hi. My name's Ben Dean. I'm a games programmer. I've been in the games industry 21 years now, and I've come to C++. I came to C++ early, but in the last few years, I've really been liking modern C++ and presented at a couple of conferences. I blog occasionally, and for today's debate, when I saw John had the great Functor debate and Jackie's blog post, I had to reach out to John and say, I'd like to be in on that. So those who know me sort of might think, I have a bit of a reputation for being a functional programmer geek, applying that to C++ a bit, but I'm not necessarily going to argue the side you might expect today.
All right, so it's going to get interesting. And that was one of the things, when they did the CppCast shout out for us, they made it sound like this is going to be a real discussion of functional programming. I suddenly realized, oh my gosh, I'm completely in over my head. I have no idea what I'm talking about now. Anyway, so the person who kicked off all the functional problem here is Jackie K. Jackie has also spoken at conferences. You want to tell us what you're doing now, Jackie?
Yeah, so currently I work at a small robotics startup in San Francisco. It's called Marble, and it's mostly secret what we do, but I've been working in the robotics industry for about 3 years, 2.5 years. Before that, I was in college. There's some echo. Sorry. Let's see, learned modern C++ about 2 years ago, and then started attending conferences, speaking at conferences, soaking up a lot of knowledge. I'm not a functional programmer. That was also my first blog post ever, I think, that we're going to be discussing today. So, yeah.
So congratulations, one blog post. You've already torn up Reddit with Flame and launched an episode based on the blog post. So good job. Also joining us is someone else who manages to get my ire up every time he blogs. He blogs under the name Funathan, but his name is Jonathan Mueller. And welcome, Jonathan. Every time I see Jonathan on here, I say good morning, and he always says, it's evening here.
Yeah, I'm Jonathan Müller. I come from Germany. I study at the RWTH Aachen. I'm in my first year, actually, now, and in my spare time I blog and write stuffs that John dislikes for some reason. And I also work on various projects. For example, I work on Memory, which is an allocator library, or on Standards, which is a documentation generator. And I'm only here. Oh, I'm only here because I made the mistake of joining a tech test last week. So I kind of got dragged into it.
I love telling this on the CppCast guys. They're very good. I have greatest respect for them. But they had a guest on who I don't think they had completely vetted, because it wasn't until they were saying goodbye to Jonathan and say, by the way, what year in college are you? He said, well, I'm starting college next year. And they realized they'd been talking to a high school kid who not only had his own blogs that he was writing, but he had his own GitHub library that he was sharing. And he wasn't in college yet. So love to tell that story on them. But it's actually about how we're all watching to see Jonathan's career and where he goes. Anyway, so lots of announcements. The thing I want to always announce first is what's going on with the conference. So C++ Now, submissions are closed. That is, unless your name is Howard Hinnett or Eric Niebler, I'd still accept a submission from you. But for the most part, submissions are closed. The PC, the program committee, that is, are doing reviews. And those of you on the PC, remember, those are all due at the end of this weekend. So that's what you're doing this weekend, is reviewing sessions. But registration is open. And you can go to cppnow.org and register. We are still open. We expect to sell out, but we're still open as of now. We're early in the phase, so there's a lot of openings still. I also want to say that some people have asked about the student volunteer program. It is going to happen again. Expect an announcement soon. The other thing is, for those of you that might be looking for this kind of an opportunity, we have kind of a special opportunity that's happened. And we're looking for a sponsor that wants their company to be a hero. For about $500, we can do kind of a special gift to attendees that I think will make it kind of memorable. So if that sounds interesting to you, because you think your company would like to be a C++ Now sponsor, but not spend a whole lot of money, contact me about that. Let's see. The other thing we should talk about, we did mention CppCast. The interview this week is with STL, Stefan Lawawade. Do not miss that. He's always very interesting. He has a great point of view, very much involved in what's going on in the standard and how a library is implemented and how it should be implemented. And he's also great at talking to users about how to improve their use of the STL and how they write better C++. So that's great. And they also had a shout out for some slides of Ben's. You want to talk a little bit about what they mentioned, Ben?
Yeah, so I guess I should try and find the blog post. Not my blog post, but a blog post that somebody made about a slide that a talk I did at CppCon back in September about using types effectively, and I presented a particular sort of way of using variant to model a state machine effectively by modeling each state with a member of the member of the union inside the variant effectively. So that talk, I'm happy to say, seems to have had some impact on the C++ consciousness of Reddit and whatever. There were several things from that talk that people seem to like, which is great. And this blog post was exploring more of that idea and how to use variant for state machines. And it's what they said on the CppCast. Jason made a comment that this is just another. This is one more puzzle piece in the picture of variant, if you like, and we'll discover more uses of variant as it becomes a mature part of the library and as people start using it. And I think that's true.
Yeah. So normally here I would probably do something of a little bit of talking about all the blogs that are out there, but I want to say something, and that is that the number and quality of C++ blogs out there is just, it's beginning to be outstanding. So so what I want to say is plant this seed out there. Somebody somebody should start a blog, a weekly blog that is a digest of all the other blogs, not just a list. Jens does that. Jens regularly publishes what he calls the blog roll, which is a list of all the blog posts in C++, which you could use as a starting point, but you should read them and then summarize them and say, because some of them are kind of aimed at beginners, some of them are very specific to certain kinds of ideas and stuff like that. And I think that would be an interesting service, and I think person taking the time to do that would get a lot out of doing it. So that's my challenge. Somebody pick up that gauntlet. The one blog post
that kind of reminds me of well, it's tangential, but there's a blogger, Dimitar Mirchev. I'm totally mangling his name. That he often summarizes tips that he's learned, and that's usually links to other resources, other blog posts. I think focusing that kind of effort with a certain kind of subject, like this is my digest for C++ 17 this week, what I learned and stuff that came out, or this is my digest for things related to the standard library.
Yeah, good idea. I'm always excited about good ideas for other people to do things. But I did see one rather interesting blog post I wanted to comment on, and that's in John Reiger's blog. So he has a blog called Embedded in Academia, and he talks very often about undefined behavior. And the recent blog post, wow, I don't actually have the name of the blog post. That's kind of bad. But it's about when it's legal to alias and when it's not. So here's one of the in the nutshell, what it is the compiler is allowed to assume that if it sees an object that is a pointer to bar and it sees an object that's a pointer to foo, where they're not related by inheritance or something like that, these are different types, and neither of them is a character type, that it's allowed to assume that they're not the same thing. When in fact, people do play these games all the time where they do this kind of type punning, and so they have this object, but they know that this set of bytes within that object are actually the exact same layout of another object, and so they do these kinds of type punning things. The problem with that is that the compiler is allowed to assume that there's no aliasing going on and that they can't possibly be referring to the same object. And there's some examples he has of where people have been bitten by real code, and there's an article that's just been, it's an academic article that was just published, where they both talk about the problem and they also talk about, someone in the chat room is helping, detecting strict alias violations in the wild. Thank you very much, Matt. So I thought that was an interesting article, and if you're interested in not being able to sleep at night because you you read about things that you realize, oh my God, that was undefined behavior and I didn't know it, that's a good one. So let's see, are we ready to start talking about, does anyone else want to bring up something else before we get into the...
Well, I was just going to say on that blog post, and in fact on the subject of undefined behavior, I think there's a lot of undefined behavior that people write unintentionally or intentionally. That a while ago I tweeted. I don't tweet very often, but I did sort of. It seems to me that some people think about undefined behavior as there's two kinds of undefined behavior. Some kind of undefined behavior that's kind of just evil in and of itself, like, I don't know, dereferencing null pointers or something you would never expect to happen. And then undefined behavior that's not evil, but it's prohibited by the standard, but it works fine on my machine, kind of undefined behavior. And you know, this John does a great job in his blog of you know, all that kind of stuff. And this blog post struck me as one of those areas that I wasn't sure which side of that line it was on. It was sort of in the compiler, and there was no, you know, restrict isn't a thing that's in the standard, for example.
Not in our standard.
Right.
Yeah.
Yeah, I guess it's a question of portability, right? Is if you know certain things about you know, GCC keywords, or if you know about what the memory layout for the function tables are for different operating systems. You just reach in, it's fine.
I think there's,
where do you draw the line?
I think there's more to it than just portability. I think this is one of the things that people are beginning to catch on to, which is, so for example, suppose I'm writing code and I know that I'm targeting Intel, and so I know the standard says that if my signed integers wrap, that's undefined behavior. But that's okay because I'm on Intel and I know what it means to wrap a signed integer on Intel.
Right.
So the standard doesn't say what it'll do, but I know what it'll do. The problem with that is that the compilers are now taking advantage of undefined behavior, because the compiler is saying that if you do something that could wrap, it doesn't matter what kind of code I generate. Now, the assumption on the naive programmer is the compiler's not going to do anything special, and it's just going to do what Intel does, and I can safely rely on that as long as I don't try to port it. That's not what compilers are doing. The compiler writer is instead saying,
Right.
oh, look, here's an opportunity for me to optimize if by assuming that it can never wrap, because if it ever does wrap, it doesn't matter what code I generate. So I then come at it with the mindset, no, the user is guaranteed that they will never wrap. And I think that's what's biting people. And I think there's some people who think the compiler writers are overstepping, but no, those are the rules, and we have to play by those rules.
That's the difference between implementation-defined behavior and undefined behavior, because implementation-defined behavior is just that, implementation-defined, whereas the compiler can't optimize regarding that.
Were you going to say something, Ben?
I was going to say I've seen a lot of this, in games, especially on, let's say, on consoles over the last decade, where when a new console comes out, these days it's much more standardized with things like Clang and whatever. But over the last decade, 15 years, new consoles came out. The C++ compilers on those consoles were maybe older versions of GCC, or they weren't as aggressively optimizing as things are today. And games programmers want speed above all else. And so if they, and some of the consoles had some esoteric hardware, which the game programmers had to learn, and you had to know what was happening at the instruction level. And you wanted to take advantage of that hardware, and you wanted to, you were writing code which wasn't going to be ported, so you were specifically writing code for, I don't know, the PlayStation 2 or the Xbox or whatever it was. And so there is this mindset of, I know what the machine is going to do, and then the compiler is, doing the wrong thing for me, by me. So that, I mean, I see that argument. That's a, and that has implications for security of code and all kinds of things. There just is somewhat of a mismatch these days between the mindset of someone programming to the machine and when they're actually programming to the spec, because that's what the compiler is, but they used to be programming to the machine, and there is that mismatch in mindset sometimes.
Yeah, and it was much less important before compilers got as aggressive as they are. And of course, the compiler writers were always trying to be aggressive. It's just they had lower hanging fruit. But now the compiler writers have both the analytical tools to allow them to do more aggressive kinds of things, and also a lot of that low hanging fruit's gone. So now they're going after more stuff. There's some interesting videos being posted in the chat room here from Chandler and Michael Spencer, and I think Michael also works on Clang. Obviously, Chandler works on Clang, so it's going to be the compiler writer's point of view here, and I think those are also very good talks. So like that. Anybody else want to?
Yeah. I also remember this huge shitstorm on Reddit when some GCC versions suddenly started to optimize this null pointer checks out, and because this can't be null pointer, but some people have it, and this was just.
Well, what happened, I think, was that there's code in the Linux kernel where you passed in a pointer, and it was defined to be safe for the pointer to be null. And so there was code that would check to see if the pointer was null, and it would do one thing if it was and do something else if it wasn't. Everything's fine. And the code got generated properly, everything. And someone came along later and they started adding some logging for debugging purposes or troubleshooting purposes. And they added some code that dereferenced the pointer and printed out what it pointed to, but it just logged it. So this, of course, is undefined behavior because they hadn't checked to see if it was null before they did that. But what that meant was that from the compiler's point of view is if this pointer is null, then undefined behavior has happened. But I'm allowed to assume undefined behavior can't happen. That's not really the way it works. What it really means is the compiler can generate any code in the undefined behavior case, and that's legitimate. But the way they implement that is by saying, I'm allowed to assume undefined behavior doesn't happen. Since there was a null dereference, that couldn't happen because it's undefined. So they took out the null check. And that's, as Jonathan so eloquently put it, that was a shitstorm. Because the Linux people said, do not optimize out my null checks. Those are kind of important. But the compiler people responded and said, write code to the standard. That's also important. And I think what eventually happened is that I think GCC has a flag that says don't optimize null checks under any circumstance. Which is kind of, again, I think it's not getting at the root of the problem. The root of the problem is, of course, understanding what undefined behavior is, and don't dereference pointers that might be null. Because I actually use that myself. I have looked at code where I was saying, oh, I want to do something here. Is it possible for this pointer to be null? And I look at other code before it. Okay, they dereference the pointer. I can assume that the pointer obviously can never be passed in null, because I don't know if you ever had this problem. I've actually worked on code bases where the documentation wasn't complete in all areas. So on a given function, you didn't necessarily know what was expected. So I do a code inspection, and the pointer gets dereferenced without checking. So I assume, okay, I can assume that it's valid. Anyway, so I think that's what is that's the shitstorm you were talking about, right? Yeah. All right, so I guess we're ready for the main event. Let's talk about Jackie's blog post. You want to start, Jackie, by talking a little about the post and where it came from? And
sure, yeah. This is, as I said, I decided to start blogging. New Year's resolution. Blogging seems like fun. I have a lot of opinions, which I keep to myself, and decided to, write them. And this came out of kind of just how I begin the post with, I had heard the term functor first in C++, because C++ is one of my first programming languages, my primary language. People talk about functors all the time. Functors are those things that are structs with an operator paren, which you can call like a function, right? And I've looked at documentation I've written in the last year or two that uses that word. And I realized that I had also been using the word in, my small hobby forays into Haskell. I had seen the word functor also forays in using Boostana, which I talk about in the post, and realized that they have subtly different meanings. And I wrote this post to kind of process that. And I gave it a really inflammatory name, which, I actually honestly expected this, because this is sort of like a practice blog post, to see kind of what technical writing is like. I honestly expected just nobody to pay attention to this. And now here I am. So
if you want your blog post to fly under the radar, stay away from the inflammatory names. That's all I'm saying.
Using the imperative tone is probably... but honestly, I think after I wrote the blog post, I learned a lot. I think it's what's important. There's kind of two things going on here. This blog post is really not about functional programming. It's about category theory, and also how we use those terms in programming. And it's also about the greater argument, I think, is not about whether or not you agree with the premise and the title, but it's about if we should care about how we use words that we've co-opted from other languages and other disciplines like mathematics and category theory. If we care about overloading words, or if we just want to let vocabulary come up organically and just keep using functors how we use them. So it's kind of my opinion.
You want to talk a little bit about the Reddit storm? I actually didn't read the Reddit storm, so I don't know.
Oh yeah.
What should I know about what happened there?
Well, it wasn't really a storm. I think I'm trying to find the post, but it could be a while. As I remember it.
While you look, I'll say what
Sure.
what my response to that is, and the reason I think about this a lot because in my training, I almost if I train anything having to do with the STL, I probably will mention Functor, and I will tell people that within the C++ community, Functor means, and this is something that I want to clarify in a second, so we'll just pass what we say it means in the C++ community. But what I say is that you won't see me personally using the term Functor, and the reason is because in functional programming, it has a different meaning, and it's well established in that discipline. And so there's no particular reason that we have to use that. We have alternatives. And I will, in fact, apologize in advance. Sometimes I'll slip up. But in practice, I'm actually pretty good when it comes to, I use the word callable. STL in CppCast is implying that the word invocable might become in vogue. But I tend to say callable because I think that's, it's more obvious what that means to most people. So if I were to say, pass in something's callable, I'm pretty sure most programmers, even if they've never heard that term before, would figure out what I mean. If I said invocable, they might also figure that out, but I think callable is probably a better use. Now, the one thing I want to say is that I actually started writing an email to Jackie when I saw her post. And I was going to point out to her, I say, well, and I agree with you, and I never do it myself, but it's in the standard, and so we're never going to get this to go away. But before I did that, I wanted to find the actual reference in the standard. And I was shocked because I remember reading this in the standard, but when I grep for it now, and maybe it's a problem of my FTP reader, I don't know, I mean PDF reader, I can't find it now. And yet I would swear I saw it in the standard. And the reason I can swear that I saw it in the standard is I so clearly remember being surprised at the definition, because I had always heard people use functor to mean a function object, meaning a struct defined of the function call overload. However, what I remember reading in the standard was a surprise to me because it said essentially anything that's callable. So it didn't mean just what I'd always used a functor to mean. It actually meant what I now use the word callable mean. In other words, it included function pointers and other things. But now I can't find that. And so now I'm, what? Where did I see this?
So I just screenshotted, and I'm gonna try to post it on Slack. I find like about 9 instances of functor in the copy of the standard I have right now. And Simon Brand is commenting on Slack. Oh, this is great conversation on Slack right now, where there are a few instances.
So Matt D has just quoted something from the GitHub, and it says fixed issues by removing. But I actually, wait a minute. But I actually, because I so clearly remembered this, I looked at earlier versions of the standard, and I still couldn't find it. So maybe, okay, well, clearly I'm way too old, and my memory is failing.
In the latest standard, I have 4640. There are 2 occurrences of the word functor, and they're both basically referring to 20.14.16 default functor traits, which is the template default order. It's not. It doesn't look like it's anything to do with function objects.
Okay.
It seems like in the latest standard, the meaning of functor to mean function object has been removed.
Okay. If anybody finds where it actually is used from an earlier version, I would like to know if I'm totally making this up. But my understanding was that in the standard, what it defined function is essentially what I currently call a callable, and it wasn't function objects only, meaning a type with a function call operator overload. And one of the things, callable. STL points this out too.
Yes.
That Scott has in some of the material that I present, I licensed some of Scott's material, and he has this example that was just the first time I saw it, it's like, that is so poisonous. Why would anybody do that? But it was actually they were making a function object, or Scott's example was a function object. It didn't define the function call operator. What it did was it had a conversion operator that would return a function pointer. And at first, it wasn't until STL mentioned it this morning. He said, well, Lambda has that. And I remember, yes, I always teach this. I say, oh, by the way, there's this magic thing about Lambdas that if it doesn't have state, you can assign it to a function pointer with that signature. And I always thought, oh, that's the one thing that you couldn't write yourself with a regular, but now I realize, oh, you could. That's just a conversion function. Duh.
Right.
So thank you again, STL, for enlightening me.
John, just to clarify, because there are a lot of people in the chat, when you mean callable, do you actually mean member function pointers? Do you include those, or do you not include those?
And pointers to member data also can be included.
Well, I generally, the only way that I would consider the member function callable in that sense is because when I use the word callable, what I'm saying is that I'm going to pass this into a generic algorithm so it can be called. So what that means is if this was a member function that didn't take any parameters, it could actually be invoked on an object, right? I mean, you could, that would syntactically work with invocable. So I guess it would work in that situation. But in general, I don't mean it that way. You could use bind, but I never encourage anyone to use bind. That's why God gave us lambdas. So we wouldn't have to use bind anymore, right? Anyway, so the email I was going to send to Jackie, first of all, I was going to say, on the one hand, this is hopeless. It's in the standard, and so I don't think it's hopeless anymore because it's not in the standard. I think we can educate people. The other thing is, I was going to say, a less imperative tone might be why I never use Functor or something like that.
And you shouldn't either.
and the last criticism I had while I'm beating up on Jackie was this long. It's not terribly long, but the blog post to me is kind of two parts. One is why you shouldn't do Functor, and then the last part is this category theory thing, which was way over my head. So the other thing I would say is, and this is, you're just starting out with your blog, keep your blog smaller and focused on one thing, because there's always room for another blog next week. And in fact, that's actually a good idea. Figure out how, I've got this really good idea for a blog. Can I stretch it into 3 weeks, right? So anyway.
Yeah, that's the issue is if you keep procrastinating on writing part 2, then you just have a blog with one post that's part 1 of 3. Yeah.
Well, the really clever people go ahead and write all 3 parts, and then they can just take vacation for 2 weeks because they just push up the already written. But in practice, what always happens is that people make comments on the first part. You have to fix the second and third parts after that. Anyway, congratulations on the blog. Does anybody else want to beat up on her?
Go ahead, Johnson.
Yeah, I don't want to beat up on her, but I must admit, the first time I heard that the term functor has a different meaning was right after I've written my blog post about function view with about 10 occurrences of the word functor directly afterwards in a discussion on Slack. And then you wrote this blog post, and then I thought, but why is everyone calling it functor then? And I did some digging to find the oldest occurrence of the word functor in the C++ context I could find, and it is in a book. The author says that functors are loosely defined as instances of classes that define operator parent, so function objects. And it's in a chapter called Generalized Functors, and the author basically goes ahead and implements standard function. But he calls it functor, not function.
Who is the author?
It's Modern C++ Design. So
it's all Andre's fault. Okay.
So on this topic, I had a couple of things to say. I think you hit it on the head, John. I mean, as programmers, we are nothing if not pedantic, and when I put my hat on as a C++ educator, it behooves me to use the right nomenclature and to be very careful about that. And that is why, to take another example, when we're teaching object orientation in C++, we don't say method, we say member function. But that doesn't mean that in everyday language, programmers talking about things still say, oh, such and such a method or whatever. And so I think there's room for, I don't think we should try to mandate a language usage, but we should be careful about our own language usage when it makes sense. And yes, if I'm writing a heavy-duty library, a Boost HANA or something which really benefits from this categorical theoretic view of the types and everything, then yes, I would totally use those abstractions in my code. On the other hand, if I'm just writing an application and I'm writing library types for my application, there's a much lower sort of cost of entry for doing that. When I write code, library types in my application, I don't do things like protecting against overloaded comma operators, that STL famously does. So C++ is sort of increasingly becoming this bimodal language where it's a language for library implementers that has to be super, super generic and super specified and very, very nitty-gritty details. And then the language for application, people who want to get their problem solved, trickle down from the one to the other, but I don't think they should be mandated.
Right. I think another example is the word lambda. I think people are very casual about that all the time. You say, well, I'll just return a lambda here. Well, no, if you want to be technical, the lambda, what we write is a lambda expression, and the object is a closure. And yet when I tell people this in class, I always tell them, don't worry about it. Everybody is sloppy about it. We just say lambda, but now you should know the truth, because sometimes we really want to be precise, because sometimes we have to explain why something that works the way it does. And the really precise is that there is a lambda expression which defines a type of which the closure is an instance. And that is the correct terminology. Yes. But if I were reading a blog post and somebody said, well, then the lambda is going to do this, meaning, of course, then the closure is that, is going to do this, I'm not going to lose any skin over that, right? I would like to think that in my writing, I'm, as Ben says, we try to be pedantic, because the compiler doesn't do what the code should do. The compiler does what the code is written to do, right? But I think there are better things to argue about, and there are things to argue about. But there's a lot of things as well, and I feel a certain amount of responsibility as an instructor. My slides should be pretty clean in a lot of ways, because people are going to take that as an example. Now, that doesn't mean, for example, when I write my slides, you'll see that const always refers to what's on its left. And I explain that to people, because sometimes people have never seen that before. What is that? And I explain why. And then I say, but I'm not saying you need to write your code that way. I'm saying I think it's clear, and so I write my code that way, and I try to be consistent. And in fact, I use the new using syntax instead of type def. Why? Because I can be consistent. And I'm not saying go back in all your code and rip out all your type defs and change them all to usings. No, I'm just saying I want to lead by example. I'm going to write the cleanest, most consistent code I can write, and I hope that I don't get crucified if I fall short of that. And I'm not going to crucify you. I'm quick to tell people, because that's what I do, to tell people why I think things can be better. But at the same time, don't feel like, oh no, you misused the term lambda, I have to call you out on that. No.
Right. Somebody in the chat mentioned, oh, sorry, go ahead, Jackie.
There's another thing STL mentioned in his comment on Reddit. He was the first one to come on Reddit. Was lambda function drives him insane. But I just quickly also, I think, John has a great point that instructors should be really careful about the terminology they use and the example they set. And absolutely, everyday programmers, I'm not going to crucify every person I find who doesn't use the right terminology, because I think what matters more is the code you end up writing, and then people who discuss these things a lot, like instructors, people who make the standard, people who speak at conferences. It behooves us to use more precise terminology for a variety of reasons. But what were you going to say, Ben?
I was just going to say, someone in the chat mentioned Bartosz Milewski's category theory talks. Bartosz presented several times at C++ Now and other conferences up until a few years ago, and I've seen him make a similar observation that we should stop saying functor for function object and start using it for in this category theoretic sense. And in the cases where we're writing libraries that benefit from that, things like handling futures or optionals or a bunch of things that are coming into language now which could be viewed as functors and monads. Sometimes it makes sense to take that point of view, and sometimes it makes sense just that, like you, I wouldn't ever upbraid anyone for calling a function object a functor.
I think, I hadn't really thought about it. I think it was because of Bartosz that I knew that, as I'm not, I don't have much background in functional programming. In fact, I remember Googling and looking on Wikipedia to figure out what functor actually means, and I still can't figure it out. I think Jackie explains it in her blog post, and even when I read it there, I couldn't figure out what it means. All I know is, from my point of view, it's a reserved word in in the sense that I can't use it the way I would want to use it, so I can't use it at all, right?
It's a mapping between categories.
Oh,
yes.
Why did you
structure.
say that?
That's the structure preserving mapping. Yeah, another point I want to make about my blog post, which I wrote and then immediately wanted to throw away, is really the like formal category definition, category theory definition, is not extremely useful in C++ because it makes us, for it to be useful, we would need to define all of our types as categories, and then think about the operations on our types. And then that starts becoming a rabbit hole of like, can we fit all that structure into our C++ programs? Another point on this topic is, I think Jason Rice or someone posted this on Twitter, like immediately after I posted it. He was like, function objects are functors, but functors are not necessarily function objects. And that's really, so it's not incorrect to call function objects functors. It's like calling every square a rectangle. It's less specific than it could be, kind of.
Okay.
Yeah.
If I don't know this, if I don't understand it, I'll just have to stick with calling rectangle because I'm.
That's okay. I think there was a topic before this, but I've kind of lost track.
Well, I think so. Jonathan, did you wanted to talk about function ref implementation, but I would rather talk about your more recent blog post. So I'll let you make the call.
Policy-based design.
You can talk about policy-based design. I can talk about the other stuff in the blog post, and then you can disagree with that blog post.
So, so Jonathan has just written a post on policy-based design, and I can't remember exactly what the name is. I should have written this down. But it was basically how policy-based design isn't good and you shouldn't use it. What was the title, Jonathan?
The problem with policy-based design.
The policy with you. And I read it, and I can't disagree with anything technically. I think the one technical criticism I would say is that we could have mentioned, Jonathan could have mentioned that the use of auto allows us to do a little bit of obscuring of types, so we don't have to be specific about that. And in fact, it kind of touches on to a concept that I talk about in my class and want to develop more, and will one day probably write a blog post about, called intentional typing, where my idea is, it's kind of my response to almost always auto. It's that one of the nice things about C++ 11 kind of, but 14 and getting more and more as we have more and more opportunities for type deduction, it allows us to only specify the names of types when we really care. If you care what the type is, you say what the name is. And if you don't care what the type is, you let the compiler figure it out because you don't care what the type is. You know, when I call a container and ask for an iterator, I really don't care what the type is. It doesn't bother me, all right? But there are times when I say, no, I need this particular type. And if I'm returning a function and it doesn't return that type, it needs to convert to that type because that's the type I really care about. Or I'm instantiating a template and I need to say, no, I want a template of this type. And if I don't care, I can use auto or I can use decal type or something else. I don't have to say the type. Anyway, all that aside, I think auto is a very nice way of saying I really don't care about what the types are. The criticism I have of what Jonathan said was, am I saying that right, Jonathan? You're Germans. The J.
Jonathan,
Yeah.
right?
And technically, you would have to call me Jonathan.
Jonathan.
Yeah, but I don't care.
Jonathan.
We should just call him Funathan.
Anyway, what I was going to say is that I think for, and again, I'm harping on this, for someone who as young as Jonathan to have embraced policy-based design, I mean, this is something that, you know, people with CS degrees don't always quite figure out what this is, right? And so at a very young age, he's all about this. He understands it. I can remember trying to read about policy-based designs in Andre's book, and I would read a few pages and I would set it down. Usually when I read a C++ book, I kind of... But with Andre's book, you read a few pages, you set it down, you think about it, you come back, and you read a few more pages. For someone to have embraced that, my thinking is that the expectation was too high. In other words, it's not a perfect thing. It has all these wonderful opportunities, and yeah, it's not perfect. There's costs associated with it. And when I read the blog, it almost sounds like the expectation is that it'll be perfect, and then when you find problems, you need to call those out in the blog. I think the first thing to do is write the blog saying how wonderful it is, and then write part two, again, me trying to milk the blogs for as many possible blogs, right? And then part two is, now here's the limitations, the trade-offs you make if you do embrace it. Anyway, that's...
Yes, the context of the publication of that book is something to bring up, John, as you say. For many of us, that book was pretty revolutionary in terms of the ideas and the concepts it espoused.
Absolutely.
So yeah, it definitely took some time to digest that book back in the late 90s.
Right. Andre was so far ahead of almost everyone else. I mean, there may have been other people who were boost authors that were kind of doing that sort of stuff, but Andre was way out ahead of the rest of us. I mean, yeah. And the thing is that with C++ 11 and 14, we have so many better tools. I mean, you know, what he could have done with variadic templates instead of the things he was, you know, the hoops he was having to jump through in the book. Yeah, an update of that book would be, well, it might be only this big because now we have a lot of stuff in the language. But absolutely great stuff. Anyway, I applaud you in I think you did, as I said, I don't have anything to disagree with technically. I think your blog called out the issues. And as I was reading, I was saying, well, yeah, but we can use type array. Oh no, you've covered the type array. I mean, you know, as I'm reading it, I'm thinking, okay, well, he has to talk about this, he has to talk about this. And the only thing I could think of that you didn't talk about was, well, you could assign to auto, and that's kind of it. Otherwise, yeah, you totally nailed it. It was a great blog post.
Thanks.
Anyway.
I can explain the reason why this is more of policy-based design should be solve everything, but it doesn't. There's a reason behind the tone of this blog post, and it has something to do with the very first library I've ever written. It was a variant and optional implementation in 2014, because those are fun. And then I decided to revisit variant a couple of months back or so, a couple of weeks back. And with variant, you have this problem of what to do when the move constructor throws when you want to change this. And there are various solutions to this problem. And I thought about it and said, well, you could do this with policy-based design. So the user can decide how the solution could be solved. And I thought this was very elegant, a very great design choice on my part. And well, someone from the standards committee, I think, on the Reddit discussion said, well, this is a problem because variant is a vocabulary type, and when you have a function returning a variant, you should be able to use it everywhere. And when you have policies, and then you have this function returning a variant with the one policy and a function accepting the variant with the other policy, those functions are incompatible. And this kind of led to the problems I've explained in the blog post with policy-based design. And that's probably the reason why the negative tone there, because I thought, well, this is a perfect solution, but then I realized, no, it isn't, and that's probably...
No, it's close to a great and it is a great solution. It's close to perfect, but it isn't perfect. There's some, gosh, it's a product of engineering, meaning there are trade-offs.
In researching this a little, and then after reading Jonathan's blog, I rediscovered scary iterators, what they're called, scary iterators, and I hadn't really looked at them before, but I went and I read part of the paper, and that goes some way, at least for iterators, to solving this problem of policy-based design. So the concept, the idea is that if you have an iterator into a vector with one allocator, you know, the paper says it's perfectly okay to assign and safe to assign this to an iterator into a vector of another category, another allocator. There's a way that can be made safe, basically, even though it looks, you know, you see the code, it looks scary, it looks wrong, the types are wrong, but the paper goes through some arguments about how that is actually perfectly okay.
All right. Well, I think we've beaten up on Jackie and we've beaten up on Jonathan. Is there anybody else we need to beat up on?
I was just trying to find a link to the scary iterator paper Ben was referring to, but the link was broken on the Boost webpage. So, alas, if anyone has that and it appears, I think it would be a good read. But oh, and one thing that came up on Slack, John, is, or if we're looking for something to talk about, is we were talking a bit about reflection. Is anyone interested in chatting about that? You know?
We have a few minutes.
Oh, we have like 5 minutes. Okay.
Yeah, we have 5 minutes. We can talk about for 5 minutes. I didn't see that, but
yeah.
What do we want to say?
First of all, joining C++ Slack was a great decision. It's full of great conversations. Really, yeah. I guess probably everyone watching will have already joined in order to participate in the chat. So this conversation came up because I was talking to Peter Bindels. Again, I'm sorry if I'm mangling your name, also known as Das Kandi, about HippoMox. And HippoMox is a single header solution to mocking for tests, single header mock framework, essentially. And he does some just awesome and non-standard, technically undefined behavior tricks for basically limited reflection to implement mocking. Like, you know, mentioned this before, reaching into function tables into memory and grabbing them so that you have like the function of function or member functions for the thing you're mocking. And so we were chatting about current proposals for reflection because we're people who think it's a good idea. Obviously, he thought so because he wrote a mocking framework, and if we had even static reflection in the language, it would have been a lot easier. Some comments in Slack about it. Does anyone have opinions on reflection before I ramble some more?
I think it's an area where the standard has a lot to answer to. We're way behind in reflection, and I don't really know what the right answers are, but I know that we want the compiler to do so much, and this is asking a little bit more, but this is how we solve problems in C++, is we ask the compiler to tell us things.
Mhm.
And we need to be able to ask intelligent questions and be able to do interesting things, because I don't think we want to add runtime reflection, or at least it would have to be opt-in, because we can't make anybody pay for it without that, right? But compile time reflection, at compile time, we should be able to ask any question about anything, anytime, and we can't do that. But the compiler has to know all that stuff. The information is there. I mean, that's, for example, decal type, right? I mean, it was like, you know, you could ask size of, how does the compiler figure out size of? Well, it evaluates something and figures out what its type is, and then figures out what its size is. It's already figured out decal type in there, you know. So, so yeah, we need to have, yeah, somebody's, Bjorn has posted the link to, I know there's a reflection group. I think it's Chandler's group. There's a study group on reflection, but I don't know where they're at or what direction they're heading. I'm pretty sure.
Yeah, so there's a
reflection.
There's a fork of Clang which has an implementation of the Reflexper proposal, and so this was kind of put on display because at Meeting C++, Louis' closing keynote had an example of this is how reflection would change language, and so it's static, you know, compile time reflection on types. It doesn't have reflection on member functions, but it does have it on fields, namespaces, and I recommend playing around with it if you have the patience to, you know, compile a fork of Clang, and wade through some documentation. But and it also requires some expertise with metaprogramming to play around with it. But yeah, I think it I don't know, for people who put in time to playing around with the language in their spare time, it is really healthy to experiment with these features if there's a compiler fork of them. So that provides justification for whether or not we should have in the language if someone's able to show they can do something really cool with it or something really horrible. Conversely.
I don't think that reflection has to be something for application programmers to do. In other words, it can be hard.
Right.
It can be for library developers only. And I always have a little bit of trouble even when I say those things, because I think that in C++, everyone is a library programmer, because I think that an object is a library, right? I think
that too. It's an unpopular opinion.
Yeah,
people think there's like...
Yeah, I remember once having a discussion. This was when I was working for one of the large companies that I worked for a long time. And we were developing a particular API because we were doing something kind of architecturally very challenging. And so we actually needed to create this API so that new code could call into old code across a boundary. And I was in a meeting with a very senior person on the team who'd been on that team for a very long time. And I asked some question, and part of his response was, well, you know, we've never made an API before. And I was just astounded because, what? Every time you type struct, you just made an API. There's an API. If you don't think of it as an API, then you're missing out on how you should be thinking about the types you create. Of course it's an API. It has clients and it has implementation. That's an API. And I think, you know, so when I say library programmers versus application programmers, I kind of hope everybody intuitively knows what I mean, because I don't even know what that means. Because I think if you're writing in C++, if you write anything outside of main, you're a library programmer.
Well, if you think about the total dependency tree of packages or libraries, think about like bisected at some point, and people who work on the lower stuff, people who work on the higher stuff, you know, that's the library application development.
I think everybody intuitively knows what I mean.
Yeah.
Yeah, I just heard you say that application programmers should put everything in main.
Yeah, there you go. Yeah, please quote me on that, because that's what I want to be known for. Having advised that application programmers should put everything in main. That's what I meant. Yeah. Anyway, we're out of time, so I want to thank you guys. It's been great. It was terrific. I want to thank everybody in the chat room, and it will take a while for YouTube to process this video, and then the video gets put out for public consumption, and it will be in the archived in the channel. And then once that's available, I will announce the next edition, which will be sometime next weekend, and we'll start figuring out who the speakers are or who the guests will be and all that sort of thing. But anyway, in the meantime, let me say to everyone, safe coding.
Safe coding.
Safe coding.
Safe coding.
Thanks a lot, guys. And bye.
Thanks. Bye-bye.
Bye. Thank you, John.
Bye.
Thanks, everyone.